Okay, so this is functions involving multiple angles, and so we have a little introduction, and so this is where we're going to get this first in the format of cosine KU or tangent KU, and K is just going to be a numerical value, a half, 2, 4, something like that. And first we're going to solve the equation with the KU in there, and just plain old solve it. And then once we're done, we want to divide the result by k. And the reason we want to wait till we're done, remember if these go for all real numbers, we put that plus 2 pi n or the plus pi n if it's tangent on the end. And so we want to put that there before we do this dividing by k so that it rotates through the correct amount of space as we go through that. And there's kind of what we're looking at. So here's our first problem. 2 cosine 3t minus 1 equals 0. And so our goal is to get 3t alone, or excuse me, get cosine of 3t alone, find the values that we would use for cosine with that fraction, and then handle the 3t part. Can I just jump to, this is cosine 3t equals 1/2. Just give me a little quick nod, yes. So this means cosine of 3t equals positive 1/2, kind of getting that alone. And then we just go through our process. All students take calculus. When is the cosine equal to 1/2? Pi over 3. So our reference angle is pi over 3, and you're responsible for just kind of knowing that table of values. And cosine was positive, so we could be in that first quadrant or the fourth quadrant for this problem. And so our angles that we would get in this piece is pi over 3 is one, and then the other one would be the one that's down over here, which is 2 pi minus pi over 3, so 6 pi over 3 minus 1 pi over 3, which is 5 pi over 3. So if it had just been right now t there, we'd have our angles and we go plus 2 pi n. But in this case, we have a 3t there. So we write our initial answer as 3t could equal pi over 3 plus 2 pi n, and 3t could equal 5 pi over 3 plus 2 pi n. And then when we divide each side by 3, or, I'm actually going to do it as multiplying by 1/3 just because it'll be easier for me to see. And so I'm going to multiply each side by 1/3 to get my kind of final results. And then that'll give me these two answers. And all of a sudden I wonder if that's going to be clear enough. But yeah, I think it will be. So t equals pi over 9 plus 2 pi n over 3. And in this case, there wasn't any reducing or anything, but sometimes there will be. And then t equals 5 pi over 9 plus 2 pi n over 3. And so those are our two answers that we end up with. And so just the thing I'll caution you about is don't get too quick in this dividing by 3 or multiplying by 1/3. Don't do that when you have these red answers here, because then you're not kind of considering the fact that revolution is happening, but since it's happening like 3 times as fast, that it'll be happening in a different amount of space as we go there. So the next one is just the same kind of problem. Oh, and I should have maybe gotten rid of some of those slides. So here's our next one, 2 sine 2t minus the square root of 3 equals 0. So just another one of this exact same kind of problem. I want to get the sine of 2t alone, so I'm adding the square root of 3, dividing by 2. So I'll get the sine of 2t equals the square root of 3 over 2. And I just go through this exact same process. All students take calculus, and I'm leaving that 2t again right now. When is the sine square root of 3 over 2? Oh, when is it? Pi over 3. That's why I went oh, because it's the same. Our reference angle is pi over 3 again. And again, it was positive. And so sine is positive in the first and second quadrants. And so that's where we'll have our angles. And one of the angles is just the pi over 3. The other angle is going to be right here. And, oh, well, really right there. So the reference angle is pi over 3. This is pi minus pi over 3. So 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. So those would be, you know, if it had just been sine t equals this, and we were just going from 0 to 2 pi, it would be those answers. If we're going from for all real numbers, because we weren't given any restriction of just going from 0 to pi or to 2 pi. So we have to use all the real numbers as we go. But now this is the point at which we say, okay, it's really this 2t, 2t that equals pi over 3 and then plus 2 pi n. And it's really 2t that equals 2 pi over 3 plus 2 pi n. So now is when we divide by 2 on both sides and kind of see what happens. Or multiply. I like to multiply by 1/2 just because I have the fractions there already. 1/2 on both sides. So I'm not changing any values or anything like that as I go. So then I get t equals pi over, am I 6, correct? And then what happens on that back part? Plus pi n, because the 2's are going to cancel. So plus pi n. Same thing here, t equals 2 pi over, oh, just kidding, not 2 pi over. What is t going to equal? Pi over 3, because the 2's will cancel there. So pi over 3 plus pi n. And so the big thing there is just when to handle that that multiple angle kind of indicator. And so the 2 that we just did were sines and cosines. So we were adding 2 pi n. We have one that's tangent. So if it's tangent, we just add what at the end here? Pi n, because its period is just pi. So that's our next one. And so here we have 3 tangent, and it's a division problem, x over 2 plus 3 equals 0. So the tangent of x over 2 is going to equal what? -1. And so, you know, when we do, all students take calculus, first of all, because the tangent has a period just of pi, we'll just go from 0 to pi and then kind of do revolutions from there. And tangent is +1 at what? Pi over 4. It's where sine and cosine are both the same. So our reference angle is pi over 4. Oh, and I forgot. Since it's negative, we're not using that first quadrant, we're using the second quadrant. And so our reference angle is pi over 4. And so our actual angle with the pi over 4 right there is going to be 4 pi over 4 minus pi over 4, which is 3 pi over 4. So that's that part of it. Then in this case, we just have this one thing, and it's repeating by pi over 4 before we handle this x divided by 2. So now we say x divided by 2 is equal to 3 pi over 4 plus what? Just plus pi n. And in this one, since it's a half angle, we have to multiply by 2 to get that alone. And then we get x equals, what will that first part be? 3 pi over 2. And then plus 2 pi n. So it's going to sweep it kind of all the way. Because tangents period is just pi. And so we just go from 0 to pi for that one. Then the other way to handle this is using inverse functions. And so really think about the fact that we didn't do it this way, but we could use an inverse function here and find that. And really really when we want to do that is often going to be if it's not, suppose that wasn't -1 or wasn't the square root of 2 over 2 or wasn't 1/2 or wasn't the square root of 3 over 3 or whatever. So what if it's not on the table? Then we can still represent that value without knowing it by using the arc sine or the arc cosine or the arc tangent. So that's kind of the value. We'll also use it for ones that are on our table, but here's a quick review of the inverse functions and just a reminder. So if the sine of y equals x, and we have all students take calculus. Remember, for it to be an inverse, we can't like wrap around, or continue to have those. So we just use these two quadrants for sine, and so we get all the negative values and all the positive values. And whatever our reference angle is, if it's a positive fraction ratio, then it'll be in that first quadrant. If it's a -1, then it'll just be the negative of that angle. And so then y equals the arc sine of x. And for this one, the domain is from -1 to 1. So just a nice little review of this. And then the range is from -pi over 2 up to +pi over 2. -pi over 2 to +pi over 2, and it includes those two as well. And then if the cosine of y equals x, all students take calculus. What two quadrants do we use for arc cosine? Say it again. The top two, yep. And so here the cosine is positive, here the cosine is negative. So y equals the arc cosine of x. Our domain still from -1 to 1, and our range this time from 0 to pi. And so from 0 to pi. And here the reference angle, if it was a positive ratio, the reference angle is the angle. If it's a negative ratio, the ratio is negative, then it'll be over here. So we have to kind of think of the reference angle and then subtract that from pi. And then if the tangent of y equals x, all students take calculus. And if now, just also notice this. We just did a tangent problem, correct? And we went from where? 0 to pi, correct? Because that's what we have been using as the period. If we approach it as an inverse function, we're going to use what two quadrants? Do you remember? The same as sine. And so we're going to use 1 and 4 there as we go through that. So just, y equals the arc tangent of x. The domain now, because these are the tangent functions. The domain is from negative infinity to positive infinity. Remember, kind of the look of tangent is like that. So our range used to be negative infinity to positive infinity, but now that's our domain. Negative infinity to positive infinity. And then our range for this one is from negative pi over 2 to pi over 2. But what do I have to be careful of? That they are asymptotes, so I can't include them. Negative pi over 2 to pi over 2 as we look at that. This one? Okay. Okay, so there's our little kind of miniature review. And then we're going to, there was my last miniature review. So now we're going to do a couple of problems like these. And so I can't remember if we did this yesterday or the day before. Secant squared x minus 2 tangent x equals 4. The issue with this one is we have secants and tangents, and even if I move the 4 over, it's not gonna be something I can factor with secant squared and the tangents. So I want to use a Pythagorean identity. Do you know what one it is? Yes, 1 plus tangent squared theta equals secant squared theta. And, since we also have a plane tangent, it's this one that we want to change everything into. So, and it's kind of as is. So I'm going to change this into 1 plus tangent squared x, because that's what it is, minus 2 tangent x. And is it okay if I just move that 4 over at the same time to just kind of get them all over there? So I'm going to subtract 4 from both sides. Minus 4 equals 0. Now I'll clean it up a little bit. Tangent squared x minus 2 tangent x. And then I have a minus 4 and a plus 1. So minus 3 equals 0. We did talk, for those of you who were gone yesterday, about, the fact that, well, this one isn't going to be too bad to factor because it's 1 tangent squared, so it's going to be tangent x times tangent x. But when that number out in front is not a 1, that seems to be challenging for people. I continue to use guess and check in my own life when I'm doing that. And it's really the same as that box method, but I just don't write the box, I guess is how I would say that. So whatever works best for you, just try and do that. So tangent squared x is tangent x times tangent x, and I don't have a lot of choices of things that multiply to be 3 and give me anything. So 3 and 1, so the 3 is negative, the 1 is positive. And so then my two situations are that the tangent of x equals -1, and the tangent of x equals 3. So in this case, this one is, and this is specifically using inverse functions to solve these. In this case, this one is on the table, but this one is not, correct? So this is the second one we'll just handle as saying the angle that we're looking at is just going to be the arctangent of 3 as we go through that. So I'll write both of them that way, but this one we can kind of do a little bit more. So x equals the arctangent of -1. And so now that I wrote the words arctangent -1, I'm going to be using from negative pi over 2 to pi over 2 for my little table of values. And then x equals the arctangent of 3. And notice it didn't give me a range, so I am going to have to go the plus pi n when I get that far. So here all students take calculus, but now we're using that first or fourth quadrant, and it is negative, so we're going to use that. We already did one like this. What was the reference angle? Pi over 4 is the reference angle there. And since it's down there in that lower quadrant, then that's going to be negative pi over 4. So for this left one, x equals negative pi over 4 plus pi n. And that's how we'll get to the rest of them. And so really, kind of think about that. It's not the half double angles or anything. But if I'm here and then I go add pi, I'm just going to be over there, right? And so that is the other negative one that I'd get. So it's just starting with the negative one and then getting the positive one and the next one and the next one, instead of before when we weren't looking at it as an actual inverse function. We were just saying, oh, okay, the negative one is there, and then we're still adding pi in, so we'd be to there and then to there, and we'd get the same things. And then this other one, which is not on our table, we're going to say x equals the arc tangent of 3 and then plus pi n. So in this case, say it again. And then, yep, we'll leave it like that. If it's not on our table of values, we'll just kind of leave it as is for that kind of problem. Now our next problem is an application problem, and it's a little involved in the formula, but you're given a formula, and so let me find that kind of. And really then once you put it in the formula, it's not that bad. If you notice, as we've gone through this chapter, I don't know if you ever look at those little introductory slides for each lesson, they have some little pictures. And this one is about a honeycomb. And so this is a rule or a model for the surface area S in square inches of a honeycomb cell is given by this. And so I will write it because I am going to have to use it. S equals 6h lowercase s, which I'm going to write as kind of a cursive, plus 1.5 s squared, bracket, parentheses, square root of 3 minus cosine theta. And, they're writing it like this. You could write it as a fraction. I'll write it like that as well. Over sine theta, and then close that. Where 0 is less than theta, which is less than or equal to 90 degrees. So it's in degrees. It's in that first quadrant. So, all of our trig functions are positive. And, you might be thinking, why would anybody care about this? But, the bee population has been like an endangered thing lately, right? Because, we've had bee populations dying and people not knowing why. So there are people who need to be kind of, on top of the whole bee thing because they are our pollinators, right? And so there's a lot of domino effects that can happen. They probably are, yeah. And so where h is 2.4 inches, and S is 0.75 inches, and theta is the angle shown in the picture. So you've got this kind of little house looking thing, and it's that angle kind of in the back there. If you're looking, that's where they showed that one. And so partly this is just a typing exercise, correct? Because, they give you everything you need. So S is 6 times 2.4 times 0.75 plus 1.5 times 0.75 squared. And times the square root of 3 minus cosine theta over sine theta. Oops. There we go. And so we've got all that. So really, all of this, right, can kind of be moved over there as we look at that. And I have just the next thing written down. I have that that's 10.8 plus 0.84375, and then times this, oops, parentheses, bracket parentheses, minus square root of 3 minus cosine theta divided by sine theta. And then the approach that's given for this one um, gives you um, if you kind of subtract or put this in a graphing calculator, or your calculator does this as well, right? You can put a rule in there and look at a table of values. So essentially that's what you would be doing for this one. And I have, this is kind of what that looks like. And the question asks, what was the angle at which you'd have the minimum surface area? So the minimum surface area is going to be where you have a minimum there. And so with these calculators, I don't think they give you a minimum, do they, or a maximum or anything? But you can use a table of values to kind of estimate where that is. And so then that minimum is here at 54.735623. And then kind of using that same idea, it says for what values of theta is the surface area equal to 12 inches. So wherever 12 inches would be, then you get from 49 degrees to 59, or 49.9 to 59.9. So, you know, I'll just estimate. So that's going to be kind of here and here, and then that's where it's below that or above that. And so I do have the answers on there for you to kind of look at if you want to try to get a little bit close to that. So that is that part of the lesson. I'm going to stop the recording now and just restart for doing some of 5-4.